Physics
Bites,
Bites, a science podcast in English by the students of Notre Dame d'Ascension.
Alright, so we're back for our third episode of our Physics Bites podcast. This time, our two guests are Elie and Alexandre, and they're going to be talking to us about the Big Bang and the beginning of the universe, inflation, and all that good stuff. So, how are you guys doing? Are you guys ready?
Yes.
You're going to have to speak a bit louder so we can hear you well, right? So, as usual, we're going to start maybe with you guys giving us a short summary about what you guys talked about, just the basic elements of what you guys researched, and then we're going to move on to the question and answer part. Okay?
Okay.
So, who wants to begin? All right, Elie, can you begin for us then?
Yeah. So I talked about the Big Bang and the inflation. So the Big Bang, it's a leading explanation about how the universe began, and so we saw also when did the scientists came up with the Big Bang theory,
Right,
and
the origin
proofs,
of this theory. Okay.
and the proofs of the Big Bang.
Okay, so the different elements in the theory and how they were able to prove
Yeah.
that they were correct or they fixed it up. Okay.
Exactly, and then so at the end we saw what is going to be the future of our world and city.
Or what the possible
Yeah.
futures are, because I don't think we can be sure. All right, so how about you tell us about the history of this then?
And before that,
Yeah,
I
Alexandre.
talked about the universe. It's a composition, like it's composed about with stars, galaxies, etc. And I talked also about inflation, like most known as the cosmic inflation theory.
Yeah.
Which is like the universe expansion.
Right, so right after the Big Bang, there's this
Yes.
period of very quick expansion. So let's begin with some of the basics of it. When did we come up with this theory?
Why?
When?
When? So in 1927,
Okay.
Georges Lemaître. So he.
He's a Belgian physicist.
Yes, he's also a monk, and so.
Yeah, and a monk.
And so in one of his books, so he came up with the Big Bang theory, so that our universe started at a primordial atom and then.
Right, so it starts from a little point and
Yeah.
it suddenly expands. And this was mostly because about 10 years before there was the theory of relativity that Einstein came up with, and he was sort of basing himself on this. Okay. What other very important event happened in the 1920s that sort of confirmed this idea of the Big Bang and the expansion of the universe?
I think Hubble.
Yeah, Edwin
also,
Hubble.
In 1929, I think he made some observations. So
What did he observe exactly?
So he saw that the galaxies around us are moving faster and faster, and so he was thinking maybe that they were propelled by an ancient explosive force.
Right, so he was observing that
Yeah.
everywhere he looked, stars and galaxies were going away from us.
Yeah.
And not only that they were going away
Faster.
faster and faster. So the further they were, the faster they were going away. Okay. And so his idea from this observation was to say that there was some sort of an explosion at some point.
Yeah,
Right.
yeah.
So on the one hand we have Lemaitre who comes up with the theory where he
And-
tries to explain it, and on the other hand we have an observation that sort of goes in the same direction. Okay. What else was there interesting in the history of the development of all these things that you guys remember?
We've talked about the beginning of the universe and its composition. Like there is a different material. Like all the atoms have been created during the Big Bang.
Right, and
not
what was
all,
the name
but
of this process that you guys talked about?
the cooled nucleosynthesis.
Nucleus synthesis.
Nucleosynthesis.
Right. So the creation of matter. Basically.
Yes.
Okay. Anything else about the history of what you guys talked about, the Big Bang, the universe? What about the composition of the universe you were talking about?
The universe is composed by many things. I've talked about it just now, like galaxies, stars, planets, dust clouds, light, and time.
And so it's interesting because I remember in your presentation you talked that at the beginning there was no stars and galaxies, and then there's after a few 100,000 years something happens. Do you want to give us a short summary of what happened at that point and nucleosynthesis and all these things?
Yes, I can. So after 380,000 years, the nucleons could be trapped into the atoms, and this is the creation of the matter at this time. And it has been so long because the temperature has to go down because it was like too hot for the nucleus to for the electrons, to be trapped in
right, because we remember that a couple of years ago we were talking about that temperature is a measure of how fast things move, and when something is too hot, things move too fast. And the electrons and atoms and these nucleons, there was so much energy that they were moving so fast that it wasn't possible for them to stay together, and in order to form an atom they have to all stay together. So it had to get cool enough until their movement was slow enough that they could do this. Okay. And let's move on to questions and answers. All right, so we had a lot of really, really good questions from everybody. Were there any questions that you guys liked that you want to answer first? Yeah?
Yeah. I really like the question on why should we know how the universe began?
Right. I think it's a question from Medina.
Yes.
Who had 3 pretty good questions, and one of them was, why should we know about the creation of our universe and how it was created? So, why did you like this question, and what is your answer?
Because it's a question that I asked myself, like why all this science, why we had to prove some things.
Yeah.
And then I imagine if there wouldn't be science in the universe, and like I deduce that it would be boring. Like a little.
So for you, it's a question of because it's interesting, and otherwise things would be boring.
No, but like if we want to, I think that if we want to understand ourselves better, we need to understand our origins, and so.
I'm not really at all a scientist person, but yes, I think it's very interesting to know how humans came to Earth and begin the life.
Right, so the origin, I mean... Medine, did you have an answer to your own question, actually? Why we should know why our universe and how it was created? Do you have an answer to that yourself?
I would say that I think that it could be better to understand, or to have a better understanding about our world, but...
So I guess there's no practical necessary. I mean, it's not easy to necessarily find a practical reason for it, but we don't have to do things only because they're practical, right? Yeah, I found that question interesting as well.
And I think that the answer at this question will explain many other questions.
That's true. So what you're talking about is by trying to solve this problem, we develop tools that we can use to solve many other problems which might be more useful, right? That's true of most things we do in science. So that was an interesting question. So let's stick to another question from Medina. It's like, there are 2 questions, I'm going to put them together. She said, so why did you guys in your presentation mention multiple universes? And why do scientists talk about parallel universes? Do you have an idea what we mean by that, maybe?
But I didn't understand this question because we didn't talk about the
I thought at one point you mentioned it, but...
really?
Yeah.
Maybe the different trajectories of the universe?
Maybe that's how it was understood, but Alexandre, yeah?
Maybe it has to go with the bubble theories.
I think that's what it was as well, right? So can you tell us what it was, this bubble theory of the universe, or the universes?
I think that the bubble theories, I'm not sure, but the bubble theories is like a universe is a bubble, which with the inflation is growing and getting bigger, etc. And these multiple bubbles are all linked together.
So the idea is, for example, imagine we have something like a surface, and then one point in the surface suddenly becomes bigger and becomes a bubble. And other points can do this, and each of these bubbles sort of can correspond to a universe. So our universe is just a tiny bit of just this tremendously, unimaginably bigger universe that has suddenly grown through expansion. which means that there may be other bubbles with other universes and maybe other laws of physics and other forms of life, and the possibilities are actually endless. So let's see, what other question we have? So there was a couple of questions about, is the universe going to keep on expanding?
So now we think that yes, it's gonna keep on expanding with the discovery of the dark energy.
Dark
so
energy, we're going to come to that
we're
too.
gonna come to it, but not infinitely. So we think that if it keeps expanding, at one point there will be a kind of a big freeze.
Right.
And because density will be so low and the temperature
so low as well.
so as well. So
Okay.
there will be an end.
So you mentioned dark energy. What is this dark energy? Is this like evil energy, or is it like just?
It's like we invoked this component with the observation that all the galaxies are expanding, are moving from each other faster and faster, and so to explain this repulsive force, we invoked dark energy, and it's dominant in our universe. I think it's 69.4%.
So if I can summarize, the idea is that we want to understand why is it that the universe is expanding, but also why is it expanding faster and faster.
Yeah.
And so the idea is to say that maybe there is some sort of a force that's pushing everything away, this repulsive force that you're mentioning, and that the origin of this repulsive force is this mysterious form of energy. And in physics, whenever we don't know what something is, we put dark in front of it, and it becomes dark energy, dark matter, dark force. And that's the idea. So it's an attempt to explain why the universe is expanding faster and faster. Alexandre, were you going to add something?
I just would like to say that it is a mention that had been created to explain a phenomenon that couldn't be explained with the words and the
laws of gravitation, the stuff that we already have, right?
Yes. So many times scientists create words to explain non-possible
So
things.
what you're describing is when what we observe and our theories don't correspond. When our theories can't explain what we observe, at this point we're like, okay, there must be something else, and usually that's a good intuition because we end up finding new things. Okay. There were a couple of questions here from, I think, Noémie and also somebody else. So this idea of the speed of the inflation of the universe. Do you know how fast the universe is expanding?
We know that it's...
After researches, we found that the universe is expanding faster than the speed of light.
Mm-hmm.
And we didn't find a precise number, but
yes, because we found some numbers, but they were all different, so we don't know which one to
go with.
Yeah.
Okay.
And I think it's an hypothesis, but maybe it has gone faster, just after the Big Bang, and it's
So you
going
think the speed of the expansion is
slower
slowing
than
down?
Yes. I
Interesting.
think
That's
it's an
interesting.
hypothesis.
I guess the Hubble constant, which was one of the discoveries of Edwin Hubble, is a number that sort of gives the speed of expansion as a function of how far they are. And so with this idea of expansion, there was an interesting question, which is a follow-up from Noémie. So have we observed that the temperature of the universe has gotten less since we've started measuring? Has there been an observation of the evolution of the temperature of the universe?
I think.
I don't know when was the first measurement of the temperature, but we know that the temperature of the universe is going hotter through the year, because it has increased 10 times through the 10 last billion years.
So the question of temperature of the universe, I think we're going to talk about it later when we have Nicolas and Milan, who are going to talk about cosmic microwave background, because that's basically this idea. Maybe we can ask them this question if there has been any precise measurements of how much the temperature has changed, but I think what they're going to say is that it depends on how precise the instrument of measures are. but we'll keep the question for there. It's an interesting question. There's a couple of questions about the Big Crunch.
Yes, and just to come back on the temperature, I didn't really understand why it's getting hotter and hotter, because it's expanding, and like the density, there's less and less density, and so it's like it's.
So you're saying
for me, it's
if it was
kind
like
of
a gas, we know that gases when they expand, they get cooler because of the law of perfect gases that you guys have studied. So you're thinking the universe should behave in the same way.
Yeah.
But it's
I don't
not,
really
so
understand.
you're wondering why that's the case. That's a good question. These are the kind of questions that we have to ask.
Yeah.
The Big Crunch. There's a couple of questions from Josephine about the Big Crunch. Can you tell us what the Big Crunch is? If it's a thing, a real thing.
So the Big Crunch. So we sang during the 20th century that it will be the fate of our universe during a long time. So it's beyond critical density. So the spreading of the universe stop.
Right.
And it is transformed into a kind of contraction.
Right, shrinking again.
Yeah. And then so the Big Crunch is like the reverse of the Big Bang.
The expansion, right?
Yeah.
So so her question was, if that's the case, what would be the main cause of the Big Crunch then? And you talked about critical density. So what's the link there?
So it's when the density is so high that's just the.
But what is the force that's responsible then for the Big Crunch?
Gravitation.
Yeah. Right. So if there's more mass, there's more density, the gravitational force. So what would be the force? There's the force of expansion, and there's the force of gravity which wants to stop the expansion.
Yeah.
And as long as one of them is bigger,
well,
we're going to go in that direction. So that's why you talk about this critical density. If the mass is higher than a certain amount, which is another reason why we need to make these measurements, so we can know if there is enough mass, if there's enough energy in the universe, so that it's enough to go over this critical density or not. So a very simple technical question: how did Hubble prove that the universe was expanding? How was he able to tell when the stars are going closer or further? How do we do that? What is the key there? Do you remember?
I think
it has something to do with light.
Oh yeah, okay, yeah. So it's like a redshift.
The redshift, that's right, right. What is the redshift? Can you tell us?
So it's so he saw that the galaxies and stars that are moving away from each others are red, and so we know that the long of the wavelength at the end it's red.
Okay.
And so he deduces that if they are red, that means that they are moving away faster than.
Right. So I'm just going to put in a few details. The idea is that we know, for example, what the color of the light coming from a star should be based on its size, based on a lot of factors. So we know that it should be, for example, at this color. And then he was observing that they weren't exactly at this color, and they were shifted towards the red. And like we're going to be doing, any of you guys who are doing physics, we're going to be doing the Doppler effect. Doppler effect is when you listen to, for example, a siren, and when it's coming towards you, the sound sounds higher, and when it's going away, it goes lower. The frequency changes based on the movement of the object towards the observer. Well, the same is true for light. So if something is coming towards us, we say it's blue shifted because frequency is going to go higher. It's going to go towards the blue, and when it's going away, it's going to get red shifted, meaning the frequency goes lower, and that's how he was able to do this with the redshift. That's good. Did you remember this? Did you guys have an idea about the size of the universe and the size of the observable universe?
We don't have an idea about the size, but we can explain you what is the difference between the universe and the observable universe.
Yes, that's a good question to answer, yeah.
Like, the universe is all the matter, the galaxies, the planets, etc. And we don't know how far it extends. We just know how far extends the observable universe, which is all we can see of the universe with a telescope or with.
And to see something, it means what exactly? How can we? So what does it mean that I can see something, and when I can't see a part of the universe? What does that tell us about the light? So it means that the light has to reach us, right?
Yes.
And if something exists but it's not observable, in that case,
it is that it is too far,
right,
and too long in the time.
So we said that the age of the universe is about how long?
13.8.
Right, 13.7 or 13.8 billion years. And so that means that light has had 13.8 billion years to travel from wherever it started to reach us. So if something is not observable, it's beyond this, that means it's further than 13.8 billion light years from us. Which means that the universe at some point was expanding much faster than light, right? I think you guys gave us numbers, right? Something like 92 billion light years across the universe, and like 40 billion light years across as an observable universe, something like that, no? Does anybody remember that? Phil?
Yes, the visible universe is at least 93 billion light years across.
Right, so something interesting happening is 93 billion across and then 13.8, but anyways, we'll get to that maybe another time. All right, well, I think that's all the questions we had. Did you
It was
find
very
it?
interesting to
Yeah.
see this subject, to prepare this subject, because it learns us a lot of things.
Right, and it's
Interesting.
pretty funny to think that we who have such short lives are able to kind of figure out all these things at these scales, which are just tremendous. All right, so if nobody has any more questions, we're going to thank our two presenters here. Great, and so that's it for this time, and next time we're going to have two of the other students who are going to be talking to us about the cosmic microwave background radiation, and also we're going to have another podcast soon talking about the Manhattan Project. So thank you very much, guys, and have a good day.
Thank you.